Okay, so let's take a look at number 5. So I'm asking you guys about this right now. So it's a little bit different. We're gonna do acid base. A couple things that you guys want to know about acid base is something called neutralization reaction. Okay. Right now, in general, we're gonna deal with a strong acid, strong base. Instead of using with weak one, which is gonna mess up our calculation a little bit. But yeah, we're gonna do with strong acid, strong base first. We'll talk about acid base later again, so you will definitely see these again. So do not forget your stoichiometry. Okay, so let's take a look at our stoichiometry. Let me just make sure. Okay, so we have the questions that what volume of this molarity of HCl solution. Again, I want you guys to pay attention to the question. Okay, it is asking for volume, so you can say either liter or milliliter, right? Volume. We're looking for volume, and it has to be HCl. So make sure you are understanding that one. Okay, needed to completely neutralize. Again, we'll talk about that in a second. 25 milliliter of this. Okay, so that's the other guys. So again, question here is if you have molarity and you have milliliter, what do you think we can find out? Moles. Okay, that should be always the case. With this information, we could find our moles. Okay, and the mole that we're gonna get would be NaOH. Agree? Because we're using NaOH, it can only be NaOH. It won't be HCl, not yet anyway. Question? All right, let's take a look. So when we say net neutralization reaction, it's basically saying acid and base will react together and they're gonna cancel each other out, basically. Because remember, we said that acids, the job of acid is to donate proton to give away that H plus. The job of base is to accept that H plus. Okay, so if we're writing equation, you're gonna have it here is this HCl plus NaOH. Go to. I don't know if you remember, HCl is gonna give away H plus. Okay, who's gonna give it to? It's gonna give it to NaOH. Now in the NaOH, specifically speaking, who's gonna take that H plus? It's gonna take the OH is gonna take it, right? So OH is a minus plus H plus. That's gonna give you H2O, water. Okay, now let's talk about leftover. Who is our leftover? Cl minus and an Na plus. So if you want, you can write them together like that. Or if they were asking for the if they're asking for the net ionic equation or complete ionic equation, you can break them up into ion. So that's my equation. Or I have H plus plus Cl minus plus Na plus plus OH minus go to H2O plus Na plus plus Cl minus, meaning that is this will be complete ionic equation, right? So we could have two different one, whichever one is, and then if we were looking for net, you would just like cross those out, and then you will have whatever that's left over, that would be the net. Make sense? So this is what we kind of talk about acid-base reaction as this. They always producing waters, and they are making some sort of salt. In this case, our salt is NaCl. Okay, now would it always be the case like always clear like this? Yes and no, because sometimes acid-base reactions are a little bit more confusing than that, because sometimes we use something called weak acid and weak bases, so the question might be a little bit different. But for now, we're using strong acid, strong base, so we're gonna keep it with this way. Okay, now calculate the mole reactant. Like I said up there, we could find the mole. Remember, it says 0.350 molarity. So instead of saying molarity, I am allowed to say mole over liter. I want you guys to make sure you understand that. Molarity is always mole over liter. So instead of saying molarity, I'm writing mole over liter, and this is an NaOH. Time, I don't want a liter, so I'm going to multiply with a liter, 0.025 liter. Okay, that is basically this one, 25 milliliter is 0.025. The molarity is a mole over liter, right? The same number. Okay, that is gonna give us what? Okay, you can probably calculate that, or you don't have to. If you want to calculate that, I mean, things that multiply by 25 should be easy. Think about like quarter. Basically, full quarter is $1, is 100, 5 is 125. Right, so that would be 5, and then I'm gonna keep the 12. 25 times 3 is a 75. 75 plus 12 is 87. Okay, now I'm going to do the decimal. There's a 3 decimal places. There's a 2 decimal places. I ignoring the 0. So therefore, I need 5 decimal to give it. 1, 2, 3, 4, 5. 2 0 right there. Mole. NaOH. Everyone got it? Now, I know it would be having easier to just use a calculator, but again, like I want you guys to actually start to practice. Like I said, things like multiply by 25. College Board expect you guys to be able to multiply by 25 for multiple choice purposes. Okay? And in fact, I think 25 should be really easy. It's a quarter. Think about money, right? Because that's always go back to that. I can't do 25. I'm like, quarter, that work. Okay. Now, number of mole of reactant needed, right? So I have this one, so I'm going to convert the mole to the other moles. So we're going to say 0.00875 mole of NaOH. Okay. Now, if you guys don't want to do that stoichiometry time one by one, you can say it's going to be equal to 0.00875 mole of HCl, and then you can say it's 1-to-1 ratios, right? 1-to-1 ratios, mole ratios, right? Based on balance the chemical equation, right? Or the reaction equation. Okay. So yeah, either you say chemical or you can say reaction. Convert the volume required. Oh, sorry, you can't see that one. So again, I kind of give some sort of reason to that so that I don't have to do the other multiplication way, or you can do it. Okay. Convert the volume required. So let's try to find volume now that we have mole. Okay. Again, if you guys are not sure how to find the volume, you can always write it out. Okay. So for instance, I have a mole, 0.00875 mole of HCl. Pretty much you are spinning upside down for your molarity, because you're going to say 0.100 molarity, which is a mole HCl per liter by HCl solution. Okay, that is going to give you what? Divided by 0.1. In case you don't know, divided by 0.1 is the same thing as multiplying by 10. Okay, so move it up. 0.0875 liter. Okay, in case you don't know, this is what I do in my head. Literally this. I move that one over. I move that one over. Decimal place can be pushed left and right as long as you push them correctly. All right. Are we still here? Yeah? Okay. Any question? How to do this one? Okay. So, let's see if we can get the next one correctly. Again, always, of course, all the teacher did, their example is really easy, right? Then when they ask you to do it, they kind of get a little bit complicated. Okay. Because we kind of want to make sure that you are thinking. So let's take a look at the next one. Let's try thinking this a little bit. Okay, you gotta help me with this. Solid calcium hydroxide react with the nitric acid solution. Okay, what is calcium hydroxide? CaOH 2. Okay, make sure parenthesis around that. Okay, nitric acid. What is the nitric acid? It's come from nitrate, yeah. It's HNO3. Okay. It's gonna go to remember what's going to happen. The H is going to go to OH and form water, right? Leaving Ca with the NO3. We got to balance the charges. Unless you're writing net ionic equation, and still you got to balance the charges. Okay. Now what should we do? 2 on HNO3. That's it. Balance? Technically not. There you go. Okay. We said how many milliliter of 3 molarity nitric acid are required to completely neutralize. Okay, yeah. It's similar to what you had before. We got this, and we got this. Notice 2 different chemicals. Nitric acid, calcium hydroxide. Okay. Chances are when you have all these kind of thing, chemistry, what is involved, is always moles, right? So you gotta convert it to moles. So let's do that. So 44.5 gram of solid calcium hydroxide. Well, let's convert it. I don't know if you guys gonna be okay. I'm gonna try to do it in one step. I'll try to separate it as much as possible. Let's see if you guys can follow. Okay, zeros, Ca, OH, 2. I'm gonna convert it. Gram, CaOH2, mole, CaOH2. Okay. CaOH, I'm gonna do the brief number calculation. 40.08 plus OH 16. That's gonna give you 74.096. One more. Okay. Now here's the part where I was talking about. Instead of doing this and then do another step, I'm gonna do right all in one step. So let's see. I don't want that. Agree? I want to find nitric acids. So let's go and convert it. Mole of CaOH2 is gonna go to mole of HNO3. What's the conversion? Where do you get the conversion from? Balance equation, right? Up there, what do we got? Right, 2 of this, 1 of this. Okay. Now, we're not done yet because what is the question is asking? Molarity, milliliter, right? So I have a mole, I have a molarity, right? Backward on that one. 1 liter, 3.00 mole of HNO3. See how it go? It's just molarity, I just put it on the bottom. Do you see that? Again, if you are looking at the unit, you can solve most of the chemistry by looking at the unit. There are some of them, yeah, you're adding and subtracting that. It's hard to see with the unit. But most of them, multiplying, dividing, unit is okay. Angel? We're good? Okay. Don't get sidetracked. Now, last but not least, are we back to the answer yet? What we want? One more. 1 liter, 1,000 milliliter. Now you can stop and you can use a calculator because that's the end of it, right? And yeah, those of you guys sitting on the side or the corner, you can't see, you can definitely move up forward. In fact, I have huge empty space here today. All right, so divide, multiply, divide, multiply. You're gonna get your answer. You can now use a calculator or at least stare at it if you want to take a look at it a little bit and see if you can kind of estimate things. Okay, that would be about 9. These two multiply would be about 9. 9 divided by 3, that's 3. So 3 divided by that, let's see, about 120 or a little bit more than that. So that would be 0, 500. 500? No, 50. Less than that. Less than 50, I would say. Yeah, 40.488. All right. Okay, and then so that it would be this, and then you to do the rounding, I can go back to a question and look at it. How many suffix are in each? And you'll notice that there are 3 suffix, so I'm gonna round to 3 suffix. 40.5 milliliter, and we got it. Any question? So are we okay with writing this? So notice that how, like, even though I'm writing the long one, okay, I guess I need to go a little bit faster because people are distracted and on their phone, computer, other things. I don't know. All right. Does it make any sense? Okay. This is why I kind of using a different color pen to kind of like show you that I changed my mind from here. Right. There's another one. There's another one. There's another one. So like how you're thinking. Okay. Again, guys, I am kind of treating you guys to be taking ownership of this. Have a question, let me know. If not, we're looking at the next question. All right, let's look at the next question. How many grams of sodium, not sodium, sorry, solid calcium hydroxides are required to completely neutralize this thing? Okay, notice we're asking for 2 different things. Grams sodium hydroxide, not sodium, sorry, calcium hydroxide. I need to leave that solid alone. Gram calcium hydroxide, and then we have here nitric acid. As always, you have 2 different chemicals. What are we using to convert between the 2 different chemicals? What do we use to convert from calcium hydroxide to the nitric acid? Moles, mole ratios, right? Balance equation. So same here. We're going to use the mole ratios, except now we're going backward. Starting with this, okay? Obviously, molarity, milliliter, liter, mole, right? So we're going to start with this. So I'm going to write it down. 3.0 mole per liter of nitric acid, HNO3. I don't want it, so I'm going to do the conversion, okay? If you want, you can know that I have 25 milliliter, which means 1,000 milliliter is 1 liter, okay? I'm just showing you that what is the conversion here. Now, you don't necessarily have to write it. You can just go ahead and write it. That's 0.025 liter. That's fine. But I'm just showing you where is this coming from in case you guys are not sure yet. Okay? So that's going to give you mole. Okay, I don't know if you see. That go away. That go away. Give you mole. See that? Now, I don't want the mole of HNO3. I want CaOH2. Let's convert it. Mole HNO3, mole CaOH2. Okay. Conversion 1 to 2. 1, 2. Okay. Are we there yet? To the answer? No. We still need one more step, right? Because what did they ask? Gram. We have mole though. So let's convert. 1 mole CaOH2. I have a gram already written up there, so I'm going to just reuse it. Okay. Are we at the answer? Yeah, we're done. Equals answer. Okay. Again, you can probably kind of estimate and guess what's going to happen. Okay. Pretty much you have 75 square-ish divided by 2, basically. Well, and divided by 1,000. So let's see. point something, I think. Let's see. Sometimes it's a tad hard to do it without actually writing down stuff. Yeah, 2 point something. 2.7786. Okay, or we can convert it and say 2 suffix, 2.8 gram of CaOH2. Right. There you go. Okay. Question with how's go? Alright. Let's number 7. Number 7 is pretty much the same thing. I'm not gonna do that one. I have a hint for you guys here how to do it. Pretty much is a theoretical yield kind of question again. Okay, here is a kind of like clue to what it is. Basically, limiting reactant, meaning it's all gone. To find the excess, right? You want to figure out who is not limiting reagents, and then from there you can figure out how to break it up. Okay, so this one's slightly challenging, but I want to see how you guys make out of. So I would actually ask you guys to try this one. You're definitely welcome to work with it. Okay, I want to quickly go over the next part, titration. Okay, you guys probably heard about it or you've seen them before in the pictures and stuff like that. Titration is nothing more than neutralization reaction, where you are neutralizing the known solution, a known solution with a known solution. So basically where you don't have a concentration of one of them and you're trying to find the concentration of them. Okay, so this is what it is. It is the neutralization reaction. Where only one solution concentration is known. Right? Meaning you got to figure out the concentration of the other guy. There are about 3 types that you can experiment with. Okay, 2 of the type you kind of somewhat see them. One of them was acid base, which is what we've been doing, which is what you see always all the time. Another one was redox, which we kind of slowly go over, but we're not quite there yet. And then the third one is when you're having to precipitate some stuff, and then things kind of like cloud out and come up. Okay, so you will have 3 different types. So we said acid base, redox, oxidation reduction, and then you have some kind of precipitation reaction. You neutralize it, you precipitate it out. Okay. Now, how did redox or how did acid base and neutralization reaction, how did they work? What is the titration? Why we have to titrate it? Titration help us tell the concentration of NO. By figuring out when is the neutralization is finished, basically. So this is one like when you guys do the lab, I will set it up and I will actually do the lab where you will be getting the solution to change color. Basically, the solution will be change color from one to another when they are finished, when they have neutralized. Okay. Now, you will learn about more in detail when we talk about acid base because you will be drawing titration curve. Right now, you're not doing it. Right now, you are just trying to find when is that happening. Okay, so take a look at number 8. It seemed like really long question. which is, I can tell you, half of you guys already quit before you guys started because you look at the question and you're like, that thing is ridiculous. Okay, but in reality, not really. You just have to pay attention, pick up the things that you need. Okay, 25 milliliter of acetic acid of unknown concentration. Okay, we'll come back to that. A few drops of phenolphthalein, that's an indicator, we don't care. Acid solution was titrated with a standard solution. Okay, potassium hydroxide, which was used to fill burette. Okay, now you need to know that this guy is in a burette. Burette is basically like a very, very long things where you are dripping the solution. The solution is gonna come into here. You're dropping the solution. You're dropping the solution into that. So burette, inside there was KOH, potassium hydroxide, and then in here was your CH3COOH, acetic acid, and then that's what is happening. That's a titration reaction. Let me zoom it in so that you guys can see. Pretty much that's what we're talking about. Okay, so they said initial reading, and then they have said the end reading. So you have the 2-number reading. Guess what that tell you? That should tell you the volume of it is being used, right? They have an initial reading and then they have a final reading. So if you subtract it, you will figure out what is the differences. Make sense? Yeah. Okay. So let's go back and look at that. So in your papers, you know that this was an initial, there was a final. Okay. First step, you gotta write the balance equation. I'm gonna skip that for a second, and I'm gonna write that volume first. So because of the burette situation, that is gonna be here. The volume of KOH need to be subtraction of this. 24.87 minus 2.35. That's gonna give you 2.52 milliliter. Still milliliter. Okay, we're gonna balance this also. Write the equation and balance it. Okay, KOH plus CH3COOH. That's gonna go K with a CH3COO, and then you're gonna get H2O. Now, in some cases, you will see people write K on the back. That's fine too. Okay. Now, calculate the mole. Titrate it. That should be easy to find because you do know the KOH concentration. Concentration, volume, can you find mole? Hopefully by this point you are saying yes. Yeah? Molarity, volume, moles together. Okay. So 0.500 mole per liter. Oh, did I did it wrong? I did it wrong. It should say 22, right? Yeah, there you go. Thank you. Okay, milliliter, since I already wrote it. Okay, if you want, you can just say it to 0.022. That would be liter. But since I forgot it, I'm just going to convert it here. 1 liter, 1,000 milliliter. It's fine. Okay, that will give you, notice, mole of KOH. Okay, you can use a calculator if you want. That can definitely help you. Okay. Probably that would be a 0.011. No, not 11. It's 0.00. Yeah, 0.0. Alright. I just want to pick up more number. Anyway, calculate the concentration of acetic acid that was titrated. Okay. Now remember what we're saying. Concentration is gonna be mole ratio 1:1 mole. So since it's 1:1 ratios, right? I'm just gonna say 1:1 mole ratios because I don't want to write it. Okay. So we know that means this is equal to this. So we're gonna say 0.01126 mole of CH3COOH. To find concentration divided by volume, I do have a volume 0.025 liter. There we go, I get a concentration. Okay, so that's gonna give you, oh, shoot. I typed that wrong. So that's gonna give you 0.045. I mean 0.4504 molarity. Okay. Now, let's look at the next question and let's think how we can explain this. You have a standard solution that used to titrate was 0.250 molarity instead of 0.5. How would that change, affect the volume or standard solution required to use to endpoint? What do you think? I changed my concentration. What do you think is happening? Diluted. So did I have to use more or did I have to use less of standard solution? More? Why? Yeah, pretty much. Because you are having a least concentrated amount, that means there's a lot of liquid in there. So you should probably use more of that, right? Because it's lower concentration. So we're gonna say 0.250 molarity KOH is less concentrated than 0.500 molarity of KOH, meaning have, right, thus have less mole of KOH, need more solution, right, to get the same amount of KOH. So something along the line of this. Okay. So pretty much, like, I mean, I'm pretty sure you could write it much more elegantly than that, but something like that, pretty much what you're doing. Okay. Now, how about the other one? What if I'm using 0.5 molarity of BOH2 instead of 0.5 KOH? What do you think? Same concentration. Do you gonna need to use more or less concentration? I mean less solution. Let's compare them. What do you know about these things? They're the same molarity. So are we gonna use the same amount of volume? Less or more? Trick question. When you're neutralizing, what is being used? No, not produce. What is being used in a neutralization reaction? What is being neutralized? Take a look at this thing. KOH, CH3COOH. Which one is being neutralized? Which one is being used to neutralize thing? Which one was our key player? Hydroxides, OH here, right? So if you look at BaOH2, BaOH2 has what? This one has twice, right, concentration of OH minus compared to this. Compared to this, okay? Which means I can use less volume needed because I already have a lot. In fact, you need half only. Make sense? Okay. I think the last 2 questions you can do it. Yeah. I'm gonna leave it for you guys to try. Because if I do every question, then there's no point in you like yeah, you're passively learning. I want you guys to try this. Okay. So that's pretty much it. I'm gonna stop here.